Hi, um, this is Rashmi. Welcome to the Summer Coding Sampler series. This is session 11, and we'll be working with some fun game programming projects. So give me a quick second. I'm going to switch to our agenda for today. Okay. Please do let me know if you are unable to see, view, or hear the sound in today's meet. So we'll go there quickly. Okay, so welcome again to the Intro to Game Programming session. This is session 11 and of the BPS Summer Coding Sampler. I'm Rashmi, and I have Janelli joining me, who will be monitoring today's meet session today. As you ask questions, she will be responding to the sessions on today's meet. So quickly, today the focus is going to be designing actually some fun games. So the first one is going to be a Spaceship Meteor collision game, and we'll talk about what are some of the aspects of this game in terms of we'll be using some variables, designing some loops, and sort of also looking at how we can take a sprite, change costumes of the sprite, bring in some assets from the internet, and how do we merge those in. So that's sort of our first game. The second game is going to be about, it's a crashing spaceship light path game, which allows us to sort of work with some conditional statements, again, obviously variables and positioning of our sprites, and it's a two-player game. So that gives us multiple opportunities in terms of how we use the inputs that we are providing for player one and player two, and how that looks on into a two-player game. So we'll be doing that today. And then before we sort of jump into the game design part, which is the fun part, I quickly wanted to take you to the logistics. The BPS Learns will host the webinar, the assignments, resources, and exit ticket. I am going to post this is your session for today. That's session 11, and I'm trying to introduce more tools than just Scratch and Star Logo, hence sort of trying to get to the game programming in simulation from using exemplars. The webinar is posted here. The today's meet link is right here. And do feel free to explore some of the challenges in here, but I'll explain some of these as we get to the end of the webinar session today. So coming back to logistics, it is very important for you to keep track of your participation and assignments. So do ask us questions or let us know if you're having any problems submitting assignments. There was one question about assignment submission, so for the Python programming. So if you want to submit a program, and you could also collect them in a folder, Google folder, and share the link with us, and we can assist you in that regard as well. With some of the sessions, especially with this session and the Python, if you want to have a face-to-face meeting with me, you can come in on Friday between 2 to 3. If you'd like, you can connect online as well, or call me, and we can talk about the specifics of the projects as well, just in case you have questions. The webinar screencast will be self-explanatory in terms of how you design the games, but I just wanted to have an option in there for you to meet face-to-face if you need to sort of work with us. So today's meet link is right here. So the quick note about sources is sort of, this is just a very small link to sources, but we'll be posting in the resources section a lot of the handouts that we'll be discussing today, so which will happen right after the webinar session. So please look at it after the webinar session, especially for the resources. So quickly, if you have already attended the Intro to Scratch webinar session, which I believe happened, I believe it was session 3 or session 4, that would be a great way of introducing yourself to Scratch, which is one of the tools that we'll be using. And it is also sort of a quick introduction to we've designed a game program, which is the rock, paper, scissors game in that intro webinar session. So I highly recommend you go through it to sort of understand the interface of Scratch and what are some of the basics of Scratch programming in terms of the sprite, terminologies, what are the scripts, costumes, blocks, and what are some of the ways in which you can drag and drop some of these blocks into Scratch. So what I wanted to quickly show you were 2 other resources that would be helpful. So this is on the Scratch website. These are really great introductory tutorials about how to make your sprite move forward or make your sprite spin, change color, dance. So these are just motions that you can program into your sprite, and these are great exemplars. Make your sprite follow the mouse, which is one of the tools that we'll be using today during our programming assignment. And then sort of how can you make your sprite spin, make a simple game. This is also another great assignment to get used to sprite and the motion and programming your sprite. And this is a nice digital storytelling example that you can use. And then there are a few more quick video tutorials that help you sort of understand the structures of the paint editor tips and so on and so forth. And that's one resource. The second is, I think we did mention this in the intro session, but this is the Getting Started guide for Scratch. And it's just, it allows you to use some of these blocks and explains them really nicely. So you can use them in your classroom to introduce some of these aspects. We'll be using like color changing, key pressing. We are using adding a backdrop. We're using that. Adding a sprite, of course, we are using that. And, exploring a lot of these properties of the sprite in our challenges for today. So having said that, just quickly going back to our interface, Scratch is a graphical programming language from MIT, as you know, and it teaches programming concepts to kids by snapping code blocks into places. So it is completely free, so definitely you can work with it in an online setting, which is what we'll be doing. So this is how our exemplars are going to look like as we program them. But there is also a version that you can download, an older version, which sits on your computer, and you can work through that as well. So Scratch falls into the block languages category. So today we'll quickly take a look at Scratch, Star Logo. That's another block programming language. And then I also wanted to quickly introduce you to one of the text programming languages, Python, that allows us to do some game programming as well. The difference is the two are the block programming, and then we are going to use some text programming exemplar as well. One of the reasons why we want to transition our kids from block, get them started with block programming, and then move them to the text programming languages is because there are concepts such as iteration, recursion that are not necessarily designed for block programming, but it is a very core concepts for any programming assignments or professional programming languages. So I wanted to quickly refer to Glassdoor, which does a really great study of highest languages programming languages for jobs, and this is sort of the list of the top 9 languages, and you can see that Python, JavaScript, Java, these obviously languages change as we go through 2016 to 2017. But again, it's very critical to learn the concepts that are very similar in most of the languages, and being able to work within the text concept of languages is very important, as these are the languages that are professionally used into into the professional world. So having said that, let's go back to this. Game programming. Educators, parents, researchers feel and find, they've been finding that teaching students to write code and designing games enhances learning and creates engagement. And that is one of the big reasons why game programming has become so instrumental in teaching computer science to the kids. So we have a research study, I'm going to quickly go to that, which focuses on how educational games can help enhance students' motivation and learning of the concepts. So this is a paper that was published for the International Conference for the Future of Education, and amongst many different variables, this paper focused on how, on one of the variables which focuses on, children engagement with, different modalities of, different educational modalities, including game programming. And in their conclusion, they found that these, in the study, it was seen that a programming language education process targeting a computer game development project can affect the opinions of the students positively. Opinions of the students show that coding a computer game can enhance the willingness of learners to make programming projects. So they're more engaged in terms of, programming certain characteristics of the objects that are in their program. So that is a really helpful conclusion that supports using games and simulations in teaching computer science concepts. So this is another really great place, Common Sense Media, that talks about learning programming and coding, and gives you many different options of using code or building apps and building programming puzzles to learn computer science concepts. So we'll be posting a link to this as well, just so that you have an idea of the range of tools that are available to you. So that gives us a quick review of the programming, the need for game programming in teaching programming concepts. We also wanted to, during the sessions that we are doing, the 2 programming challenges that we're doing today, we'll be focusing on working in Scratch, which is the graphic interface that we'll be using, graphical environment. We'll be obviously changing some of the backgrounds in there. We'll be working with sprite modifying, changing sprite properties. We'll be working with introducing variables like counters. We'll be doing some conditional statements, condition controlled loops, like forever loops. We'll be creating some media assets in the Scratch editor, and also importing some assets from the internet. So that's sort of our focus for today. In terms of some of the questions, please do post them, but as we go through the assignments, I will try to answer your questions at the end, just so that everyone sort of gets a perspective of what the programming assignment looks like. And then at the end, as you have questions, I'll try to address them. Okay, Janelli is nodding. Okay, so the first challenge for today is the Spaceship asteroid collision game. And the game sort of focuses on, this is the challenge that we have, which is the Spaceship asteroid collision game. Shows us how just a few sprites can simulate a seemingly endless shower of meteors. An explosion animation will also be demonstrated, and the spaceship follows your mouse. So we'll have some mouse interactivity in there, and we'll move the ship to avoid the meteors for as long as possible. So that timer, the amount of time we take to sort of we save our spaceship, is going to be a determining factor in whether we win or lose the game. So let's look at the final animation. So let me quickly go to that. And before we sort of go into that animation, I also wanted to show you a quick review of the game design process that's involved in this. So you have like a flow chart, as you can see right in here, that allows you to sort of you have a flow of commands that you'll be designing into your program that will allow you to create your challenge or create the game for your challenge. So this is a great resource that I found on online, which talks quite a bit about the game programming concept, setting your environment, the characters, players, then you have the game modes, and this is a very generic flow chart, but this is also another resource that you can use with your students, which talks about the conceptual phase wherein you do the research. You have all the game pieces together, including the player, the environment. You have your theme, you have your content, you have your goal, and of course the constraints that you use. Then you test a concept, then you add your visuals and your whatever is your background in this case and the asset, and then you go into designing your game, prototyping, and then going through that feedback loop of testing your game. And play testing modules, smaller modules, so that you see that it's working in smaller chunks. And then you, as you are successful with smaller modules, you go in and check your whole module. You go through a feedback loop to see how your program works, and then you have your sort of final development stage wherein you check whether your user input is being taken correctly, so on and so forth. So with that in mind, let's go to our game, which is our Spaceship Asteroid Collision game. This is how I designed it, and as you can see in this, I have three different sprites. I'm the player right here. I'm going to play this game, and as you can see, the mouse is really good in terms of avoiding my asteroids, and is allowing me to play really well with the meteors. That's good, and I'm avoiding it pretty well. Okay, so having said that, okay, so I'm going to stop this, and I'm not going to. Okay, so that's the game that we are going to design. What I wanted to quickly also say that in the screencast, we are making a Spaceship Meteor collision game where we have these tiny little spaceship that is really agile but doesn't really move too fast. So our task or challenge is to avoid all those meteors for as long as possible so that we can get as high a time score as possible, which is right here in the corner. So let's see how this game is put together. So we'll click on the create button, and we will, give me a quick second, because in order to work with the screen, I have recorded a nice screencast of this. So give me a quick second. I'm going to switch to that. Okay. Give me a quick second. Okay. Okay. So in this screencast, the first thing we'll be doing is, as you see, my sprites are different from the original cat sprite. So I'm going to remove the cat sprite and then start from there.
First thing we are going to do is go into our Scratch. We're going to look at our sprite, and we are going to delete the sprite so that we can create our own new sprite. We go into the library and we go to transportation. We select our spaceship costume and we bring in our spaceship right here. We go to the second space and then we grab the top and rotate it so that it's facing right. And we want to make sure that it is spacing perfectly right, just like this. And we want that direction where the nose of the spaceship is pointed. So all of our spaceships are going to do the same thing here. We're going to make it a little bit fancier, like this. So we're going to duplicate our spaceship, and we are going to take a nice little ellipse tool and thicker than normal, and we will just draw a ring right here, like that. So slightly bigger ring that's further away, and then an even bigger ring for the third frame. So let's look at that. This is how we're going to do this. We have all 3 frames with the elliptical ring that is drawn like that. Perfect. So that looks great. Now I'm going to click onto my thing and I shrinked it, my spaceship, and now that's my it's begin. While we are making these changes, let's click on the stage, change the background to one of the backgrounds that Scratch has provided us. So we are going to go in and choose the backdrop button from the library, and I want to use this stars background. So it really looks great. And let's go back to the spaceship sprite and add some code to the sprite. So when the user clicks onto the green flag, we'll want to move the spaceship to the very center of the stage. So let's go to the blue motion category, grab the X and Y and set both X and Y values to 0. And since we'll hide the spaceship at the end of the game, we'll also want to make this spaceship show at the very, we have the show block and snap it into place right under there. Now we'll go into a forever loop and go to the control section and grab a forever block, and all this code is going to do is have the spaceship follow around the mouse cursor. So we are going to use the blue motion category, point towards the mouse cursor, and then move a few steps towards, say 10 is too fast, so we are going to make it this slow to 5 steps. And then we want to play the frames of animations. We'll go to the purple look section and grab the next costume block. So this is how it looks. Want to add a little timer to the top left so that we'll create a variable in the orange data section. So click on to make a variable. The variable name will be time. And so the very start of the program, we are going to have time start off at 0. So when the green flag is first clicked, we are going to set the time 20, and then we'll enter into a forever loop here. We want the value of the time to be the number of seconds that have passed since the very start of the game. So we'll add this wait 1 second block. We'll change them down to the 10th of a second to and then the orange data section will change the time value by 0.1. So when we run this, we can see that the time variable is sort of like a stopwatch where it's counting and the game next draws some meteors. So let's click on the paint new sprite button, and drawing these meteors will be simple. So we'll select a bright yellow color first, paintbrush tool, draw a little teardrop shape facing the right. I'm trying my best to do this, and then we can fill that with the paint paint bucket tool, and once we have that yellow teardrop, go ahead and right click on that and duplicate it to make 4 identical costumes. This way we'll have the same yellow core, but we'll have different red flames around each costume, which will essentially be our using our paintbrush tool. So we draw an outline around, say, the first costume in the yellow core part, and we can make the flicker towards the towards the back of it, and we're going to fill it up. So let's look at the second costume. We are going to do the same thing with the second costume. Draw it and then fill it up and flicker, maybe add a little bit more um, different shape to it, and that looks good, and we have filled it up. Now let's go to the costume 3, do the same thing all over again. It doesn't have to look perfect, but the random irregular look to all these costumes will make it look like flames that are flickering behind it. So that's why the changes in the costumes is very important. So let's do our fourth costume. So I have a little bit of random shape going on here, and then I'm going to fill it up with the red flame. Perfect. So I have, we'll just draw some sparks coming from out back. That way, just placing that way seems like a meteor and a flaming meteor at top of that. Okay, so that looks pretty good. Those are the 4 costumes. Now let's go. We can see we just temporarily grab one of these forever loops and put a next costume inside of it, and then double click it to run this loop. That looks pretty good. So so let's rename this sprite to Meteor 1, and we'll add all the code of this sprite and duplicate it, make it several afterwards. So the code for the Meteor is pretty simple. Let's start off with when the green flag is clicked and have it in a forever loop. And what the Meteor will do is first hide themselves and then wait a random amount of time, and then just so that they come down at different intervals, and then they will move themselves up to the very top and place them randomly somewhere at the top. Also come down in random directions. Once I'll show themselves, they start moving down, meanwhile seeing if they are touching the player, the broadcasting a game and message, and hit the bottom. They'll just hide themselves again and then start the entire process all over again. So let's start to step-by-step program this. So we're going to take the purple block, grab the high, and then we have the second, so it's the orange control section, grab the wait 1 second block. Number of seconds, we'll grab the wait pick random. We don't want it to be that long, so let's do kind of a problem. So pick random will only return the number 1, 2 always be right. So so this looks good. That would be nice if we could have just maybe around 2.6 seconds or 4.2 seconds, but we can see that. We can do the math, pull this out for a little bit, and let's change this to 10 to 50. And then grab this division operator block, put that in the front, and then have that divide by 10. Now this pick random 10 to 50 will have values like 26, which when divided by 10, so that we can have 2.6 seconds and so on and so forth. I'll give us much more random downward pouring of these meteors. So now we have to set it somewhere randomly for its X value to go to the blue motion category. We'll just set X to a random number, go to the operator section and grab the pick random, and anywhere from -240 to +40 far right side. And then we'll always want it at the top, so let's set the Y value to just +180, and we'll be at the very top. And then we also want it to point downwards, so direction and don't always want to point directly down, which so might need to add some degrees to it. And write a little bit. Just let's grab the operator section, grab this plus sign. So we want it to be 180 degrees plus or minus, say, 25 degrees. So we could grab that random block and say pick a random number between -25 and 25, and I'll add a little variance in where it is pointed, and it will still generally be pointed downwards, but it won't always be straight down, and snap that into place now. So so now we are in position. We can go ahead and show it, and now want to enter into a loop and keep moving downwards. So go to the control section and grab this repeat until block, and we can have the meteor keep going down and keep checking if it hits the player until its Y value reaches something less than -160. So in the operator section, grab that less than operator, and in the motion category, we'll get the meteor at Y position of the meteor is -160. Then we'll stop looping this loop and continue on. After the point, we'll just have the loop back to the top and forever block and hide itself and wait. So so the meteors will essentially start falling down, but meanwhile balls in the loop move downward. So grab this move 10 steps block. We also want to animate by changing the costumes through those different frames of animation that we have. So click on the purple, say next costume block, and then we also want to check if it's touching the spaceship. So go to the control section and grab this block if we want to see if it's touching the spaceship. So we say if touching the spaceship, we can then clicking on the back triangle case, we'll have the broadcast game over event, and we'll reprogram the spaceship to handle that broadcast. So broadcast message, let's say new message, and we'll say game over. So so let's add the code to the spaceship sprite and handle when it receives the game over broadcast. So when I receive game over block from the events category, and in this event we want the spaceship to hide itself because we'll have a different sprite of an explosion animate itself instead of we want to stop this other script that counts up the timer. So go to the orange control section and grab the stop block. Stop block, we don't want to stop the entire program, we just want to stop all the other scripts in the sprite, particularly the script right here, which has the timer go up as soon as it hits, as soon as it is hit by a meteor and the game over message is broadcasted. Then it will stop the stopwatch. So let's test this out, and the time will be going up, and then perfect. So now we got the meteor, and let's make a cool explosion sprite that can play once the spaceship gets hit by a meteor. We could draw this ourselves, but this kind of tricky. Instead, we could just download an image of an explosion animation off of the internet sites, and I'm going to download and then save these links. So I have a couple of explosion PNGs that I have saved into your computer, and those explosions 1 through 8, and back at the Scratch editor can create a new sprite by uploading an image from your computer into the editor. So I'll start off with explosion 1, and then for the sprite it will go to the costume tab and upload different costumes from each of these explosions. We're going to continue uploading these different costumes. So I have 5 costumes uploaded. I'm just opening them up and from my desktop and adding them to our sprite. So I have costume 8 PNG. So I have 8 different costumes. This explosion script section of the explosion sprite is pretty simple. All it does is at the very start of the program, it hides itself, hence it doesn't need to be seen until the ship gets hit by a meteor. and then it will just wait until it receives that game over sprite. So when I receive the block from the brown event category, let's make sure it starts off with the very first costume. So in the purple looks category, grab that switch costume block and switch it to explosion, explosion 1. And then we also want the explosion sprite to be wherever the player's spaceship was. So in the blue motion category, grab this go to block and click on the black triangle to set it to go to spaceship. Sitting right in the right position with the correct costume, go ahead and show it. So in the looks category, grab the show block now. All we have to do is have it run through all the different costumes now, and we could have 8 of these costume blocks in a row, but instead let's go to the orange block, grab this repeat loop block, and we'll just set it to repeat all the code of it 8 times. And then now we can just grab one next costume block and have that executed 8 times, but just so that we don't have it play as possible without a slight delay from the orange control section, grab the wait 1 section block. 1 second is way too long, and so we are going to do a very short delay of 0.03 seconds. And then after the explosion, animation is played, and we'll want the sprite to hide itself. And even though at this point the spaceship is blown up, let's give the player a chance to just consider the dark, vast emptiness of space. Good enough so that let's go and from the orange control section, grab this block and say wait 2 seconds. Then after that, it will terminate the entire program. So stop all will do that. Okay, let's try this out and green flag and start testing it. That looks nice, and here comes wonderful. So you guys saw the big explosion, and then it stopped automatically. So one meteor isn't that tricky to avoid, but let's start duplicating this stripe over and over and over again. So we have more meteors, so we have it harder for our rocket to dodge it. So maybe go to 10 meteors, and then when you play, you have a lot of meteors coming in, and so now you have to duck and figure out a way. Okay, so it sort of becomes much harder, and it is very hard to dodge the meteor. So this becomes a really great, nice little program. Animations of spaceships and also the meteors, but also have to download different animation images, and then you have to upload them to your. So you can change the looking animations that other people have also made, or you can find different explosion images online as well for this. But this is what it looks like.
Yeah, so let me quickly switch us back to, okay. Okay, my Google Hangouts is frozen. Give me a quick second. Okay, where is my? So give me a quick second. I'm going to stop with this animation. And then as we go back to our discussion platform, give me a quick second. Present to everyone. And we're right here. So one of the things that came up, one of the questions that came up was about the media assets that we exported into our Scratch for the explosions, and we'll be posting those in BPS Learns. Those were offered copyright free, but always it's a great thing to quote our resources, so we'll do that. But you can find pretty much any of these animated GIFs or make them as you make this animation. So within this first challenge, we looked at variables, we looked at looping using forever. We also changed the costumes. We brought in different assets, and sort of, you know, I think working with the Scratch editor into doing a lot of these different activities really enhance your dexterity with the Scratch editor. So having said that, let's move on to our second challenge, which is, this is a screencast we are making, which is essentially Save Your Rocket from Bumping game or Crashing Spaceship Hats game. So I'm going to quickly take you to that game, which is this game, and I'm not very, um, this is a two-player game, so pardon me as I struggle with managing both players on the screen, but this is what it looks like. And I'm using keyboard control to manage both my spaceships. So I'm going to stop this. I'm going to play it. And depending on my, paths, I'm going to okay, so one of them won because as you can see, if one of the spaceships crashes into the wall that is made by the first spaceship, then that player wins. So essentially the challenge, there are two different spaceships in here that are leaving walls of light or colors, in this case blue and green, onto the screen, and these colors are being are trailing behind the spaceships as they move around the screen. Our challenge is to save our rocket. So if I'm player one, I want to save player one rocket, and if I'm player two, obviously I want to save player two rocket from crashing into the other player's rocket light cycle wall, which is essentially this player. We want to stop from crashing into this wall, and this player we want to stop from crashing into this wall. Whoever crashes first will lose the challenge. I think as a player, to win this game, we are trying to get the other person's or other player's rocket to crash into our rocket wall. So it is a two-player game, and it is sort of hard for me to control both players' motions, but we are using the A and the D keys. If you look at your keyboard, we are using the A and the D keys to control the left and right motion of player one. So I'm just going to quickly play this, and I'm going to show you how I'm using A and the D key to just control the left and the right motion of the player. So that's what was happening. And then if I'm going to use the, again, just a second. So, yeah. And then it hits into the wall. So this is how I am controlling the key for this rocket. So that's one. And then I'm using the left and the right arrow key controls for the motion player two. So for two, I'm using the left and the right key controls. So that's what I do to make it. Okay, and it continues moving, so I can, yep. And as it crashes into the player, it will give you the I win org message, which you can essentially say the way you would like to code it into your program. One of the reasons why I've used A and D keys and the left and right arrow keys is due to its friendly position on the keyboard and the toggling that it allows me to do on the keyboard. But you can choose any keys of your choice, of course, keeping in mind the way you're using it as for controlling the player positions. So let's go ahead, and this is the code for it. This is the player one code and player two code. This is very similar to each other, of course. Player two wins, while as in player one, you have player one wins. So we're going to get started with designing this. So give me a quick second. I'm going to shift to that. Mhm. And I'm going to the, okay, give me a quick second. Okay, so I'm going to essentially I'm going to delete the first sprite, that's the cat sprite that's in the original Untitled. So I'm going to start with my Scratch editor, and with a Crashing Rockets game, or Spaceship, Meteor, Collision game, you can name it as you like. So I'm going to get started with that.
So we are getting started with the first screen. Let's delete our sprite and let's create second sprite wherein we are going into transportation and we are selecting a spaceship. Um, so we bring in the spaceship to our screen, and let's look at the second costume. We are going to want to select the entire spaceship and then face it towards the right. So click on the anchor point at the top right here and rotate it around until it's facing perfectly to the right. And the reason we do that is because all the sprites start off facing in the right direction, that the sprite faces to be the same direction as the nose of the spaceship. So we got our spaceship. So let's add the code for the spaceship. Oh, actually, first let me put the spaceship down, and we are going to shrink it a little bit, a couple of times. So that's a good size. So we're going to keep that as our screen size, and we are going to want to add some code to it. So let's go when clicked. And we're going to have to spaceship start off from somewhere. So let's say around -164. So go to the dark blue motion category and grab this go to XY block, and we'll just set this to -160 and a Y value of 0. Now having this go to XY block is exact same as having two of these X2 and set to Y blocks, and we're just going to use the go to XY since we have that anyway. Next we'll go to the pen tool category, and the pen is what we'll be drawing with. We need to set up the pen a little bit first, so we'll grab this set pen and click on the color blocks and then select this blue color for player 1. And we don't want the pen to be just there, that really thin size. So we'll set the pen size to a larger value, say maybe about 8. And then last we'll put the pen down so that it starts drawing when the pen up will cause it to stop drawing. As the spaceship moves around the screen, the setup code, we'll put it into a forever loop. So I grabbed a forever block now, and the code, let's start to execute it in the forward whatever direction and spacing, and then clicking say the A and the D, and will cause the spaceship to turn to the left and then to the right. And once we add all the code, the spaceship will go ahead and duplicate in the sprite 2, which will be our player 2. So that's our player 1. Let's go to the motion, dark blue motion category, and we need to move that fast. Let's have it move 6 steps each time. So it's moving 6 steps forward. Then the key is being held down, so we'll then have the spaceship turn to the left. So I go to the orange. If I'm going to sense, sensing category, grab the key space press block so that the space key will say it's the if key A is pressed, then turn say 15 degrees to the left. So let's go ahead and click on the block because we'll need to duplicate it for the D key. So I'm going to do that for D key, and then I say turn 15 degrees right. So I have the A key pressed, I turn left 15 degrees, now right degrees. So now I can see the execution of it, and this is how my player 1 rocket is moving. The rocket is turning to the right, and D key causes the rocket to turn to the left. So, so that motion is set. And now go ahead and set the pointer to the right direction each. And I'm going to point in direction always facing up. So one problem is with this is that we don't clear out the pen strokes that we're already creating. So we need to put that in there as well. So I'm going to beginning of the program, the green flag is clicked. We'll have the stage just run this clear pen block, and so they will clear out all the colors at the start of the game. That way we can have a fresh start. So I'm back in player 1. Next we have this ship check-in if it's touching color of the enemy wall, and if so, broadcast a message saying that player 1 has lost. So we'll go to the orange control section and grab one of these if blocks, and then from the light sensing category we'll grab one of these touching color block. We'll say that the color of the player will be same green and green pen blocks. So in that case we want to broadcast a message to all the sprite that says player 1 has lost and player 2 has won. So we'll grab this broadcast box from the brown category and we'll change this to a new message that says player 2 wins since player 1 has just crashed and lost. So player 2 wins. So we are broadcasting that if player 2 wins. So let's duplicate our sprite. We have the player 2. Because if we just run the program right as it is, and if you have the same exact code, you can see this is how it will look like. So let's press the A key and the D key. So player 2 should start off on the right side at positive 160, and we'll have player 2 always facing down at the start of the game, and player 2's pen color will be green color. So we've made some changes. Pen block, which means it has crashed, and if the crash color for player 1 is blue, so we'll change that, and then we change the broadcast message that says player 1 wins, and finally we want the left and the right arrow key to control the second player's motion. So we've made these subtle changes, and now let's try this out. Yeah, that looks pretty good. Nothing happens when they run into each other's player wall because we haven't programmed anything for that yet. So let's do that now. For player 1, we will move this off the side, and let's need to write the code that handles when it receives the player 2 wins message. Player 1 broadcasts this message whenever it crashes. So we'll just say that the player that loses will just say oh, and then stop the program. So under the purple looks category, describe this, say hello for 2 seconds, but instead of hello, we're just going to say oh, or any other message that you prefer. That player says it seems like a long okay, and then we'll have to stop the program right after it's done saying for say 2 seconds. The loop will still go over and over, causing the spaceship to move even from 1 to so grab this stop block and change this from stop to all stop other escape sprite and put that before the 2 seconds that it says. So that player 2 wins. The stop block will cause the strip to stop executing, and so the player won't move forward anymore. So everything on the screen stops once one of the player wins. And then the broadcast message when player 1 wins is that case we will still want the script in the sprite block to grab and then set it to other script. And the sprite except this time we'll just have the player say something victorious like I won, ha ha ha, or something similar to that, or better luck next time. You could do that as well. We are just going to copy these scripts into player 2, and then we click on player 2 and we'll see when I receive player 2 wins, and then we are going to make those modified changes, because actually player 2 will say ah ha ha, and when player 2 wins, we are going to say, he says I win, ha ha ha. So we made both the changes. Now we click on the green flag, and this is what it says, and it's actually showing the messages, and it seems to work all right. So that's our game, and I hope you enjoyed designing this. We do want to make sure all our keys are working, controlling the second player with the left arrow, and both be at the same keyboard playing, get the other player to crash, so you can test out the other aspect of the player 1 crashing and winning versus player 2 crashing and winning.
Okay, so coming back to our file, give me a quick second. Okay, I'm going to, we are 5 minutes away from finishing our webinar session, so I'm going to quickly go through this. This was our code for the program, which is, crashing spaceship path, save the ship game challenge, which is challenge 2. In the first Intro to Scratch webinar session, we focused a lot on the rock, paper, scissors challenge, which was, there are many versions of rocks, paper, scissors on Scratch website as well. So you can look at the intro session webinar that we've done, and then you can compare, contrast it with different challenges in here. That's a really great way of designing, starting to design your game programs as well. One of the reasons why we want to focus on game programming within the context of computer science is because a lot of this curriculum is being embedded in the CS Principles, which is the upcoming APCS Principles course. There are some challenges, and students develop a digital portfolio within which they have to showcase their projects, and game programming is one of the few projects that they actually design, and it could be a tic-tac-toe game, rock, paper, scissors, or a creative game such as these, which showcase their understanding of variables, functions, conditional statements, loops, and so on and so forth. So it's a really great way of introducing and solidifying computer science concepts for our students. I wanted to quickly show you a space. We were planning on doing this game programming assignment, a couple of them in Python. If you've seen the Intro to Python webinar last week, that gives you a quick introduction to Python and some of the graphing capabilities. And then we have the Pie game, which allows us to do a little bit more with the animation challenge. In this case, it would be like moving the cat towards the squirrel, but for all purposes, computer sees it as pixels. So to create this motion, one has to program that into Python. So one of the assignments that we'll be undertaking during our Python webinar sessions, upcoming ones, which is going to be a series of 4 webinar sessions, will be around game programming with Python. We don't have much time today. Otherwise, I would have really loved to show you how we can work with some of these game programming assignments, as well as the code that we would be doing for the cat animation program. Last but not the least is the project with Star Logo Nova, or Star Logo TNG. So the Star Logo program is, Star Logo Nova is a programming language. So let me quickly go to that. Sorry. Yep. So Star Logo Nova is a programming environment that lets students and teachers create 3D games and simulations for understanding complex systems. So it's a really great way of designing games as well as simulations using a programming language of colored blocks. It's a block programming language. Users can create games, simulations to study diverse concepts in science and mathematics, such as ecology, geometry, computational thinking, and so on and so forth. So Starlogo Nova is free and it runs in an internet browser. There is, again, a version of it that you can download and run from your computer. So you have both options, just like Scratch. It is used extensively in some of the curriculums online to showcase simulation as well as game programming. So in this case, this is the game which is about, give me a quick second. This is a game which talks about the Picture Book, Picture Book book, just Caudry or Bunny, the bear. And Caudry is a bear. He has lost his buttons and he needs to find his buttons for the overall. So the button is white and he has 60 seconds, which is the challenge. So he has to avoid all the trees and rocks and all the lions or tigers that are embedded in here in order to get to the button. And we've programmed that. So when you do a setup, you can see that the bear is right here. When you do a setup, it is giving you multiple views. So you could go into the camera view and you can see that the bear is right in the center. You can zoom in, zoom out, and then you go into the agent view. And what this allows you to do, you can move your lion you can move your bear with your keyboard control. But in here, this is how I programmed Caudry, the good button, the bad button, the tree, lion, and the world in general. So you can see that the objects are being programmed just like as in Scratch, but this allows you to move the bear. If the up arrow key is held, it will move forward by 1. So when I press the forward button, you can see that, sorry, I'm going to do the setup. Forever block, and then I can, if you can see, my bear is moving, and depending on he's turning, and then he's again moving forward, he's turning, and I can get that pink button. So I got the button, then he can turn around, and you can see that it also gives him the view of where the lion is, which is right here. So he can turn in and then move around here so that he's away from the line, so on and so forth. So it allows you to program all of these elements of this game into the Nova. So please watch out for the webinar session, which will include some of these game programming assignments. I'm sorry, we do not have time. I know I'm already over 3 minutes in this case. So let me quickly move on to, as I mentioned, this is a quick unit on lesson plan for the CS principles, APCS principles, and you see the learning objectives, which are very well aligned to the CSTA K-12 standards. So these are the CSTA K-12 standards. What I have is the revised version in 2011, but there is another version coming out. These are the National Computer Science standards, but we also have the CSTA standards mapped to Common Core state standards. So that allows you to see how how well these things are mapped out, and it allows you to sort of look at your learning objectives in that perspective, which is very helpful. This is our proposed pathway for BPS. As you can see, you have an introductory computer science course, which will hopefully lead towards a computer science principles course for our students. The CSTA standards have 5 strands: computational thinking, collaboration, computing practice and programming, computers and communications devices, and community, global, and ethical impacts. Very similar to those strands, we have the MADLCS standards, which are the digital literacy and computer science standards. And you have computing in society, collaboration, digital tools, computing systems, and computational thinking. So as we go through a lot of this curriculum, which is aligned to CSTA standards, you can see that it's automatically aligned to MADLCS standards as well, which is a really great, resource to have. Finally, assignment set for session 11, the assignments are the exit ticket, which I have posted right here. And then you have the Space Meteor collision game. We need you to create that collision game as we've screencasted in the webinar. Please do feel free to join us for the face-to-face session on Friday 2 to 3, or you can always email me with questions, especially if you have any specifics about how you can add or change the costumes or the variables or so on and so forth. And then you have the reading and journal entry, which I have posted right here. You have 3 readings, which are small, and then you have a journal entry, which is actually included in the exit ticket. So you can respond to that in the exit ticket. There is an optional go beyond assignment. Obviously it's optional, but it's completing the Spaceship light cycle path, save the ship game based on the screencast. But if you want, if you have any questions, please do feel free to email me. So that's us quickly. I will be posting all the resources I mentioned in here onto the BPS Learns, including the images that you have posted. And Janelli just told me that there were a couple of questions about from Mr. Omolo and Rich about how can we access some of the resources. As I mentioned, I will post those resources on BPS Learns. The images will also be posted. There were questions about will we get extra credit for the go beyond? Of course you will. And there was a question about implementation plan. We will be posting that very soon, especially all of us are looking at the implementation plan, and we do want you to have a clearer view of all the sessions, especially since the sessions are changing a little bit or getting added. We do want to have that in our implementation plan as you go forward, thinking in terms of what and how you want to implement CS concepts and programming challenges into your course curriculum. So next session is about 3D programming. That's tomorrow. So we look forward to joining you there. Thank you again. Have a wonderful day and keep programming. Thank you.